All righty, here we go. So let's do a quick recap, okay, of our logarithm properties. So first of all, oh, I did it again. We should be able to convert from logarithmic form to exponential form and vice versa. We should be comfortable with that. Okay, this is something we talked about yesterday. Okay, so you should be comfortable converting back and forth excuse me, from logarithmic form to exponential form. Okay, so that's true with stuff like numbers, right? So like I could have log base 2 of 8. By the way, what is log base 2 of 8? 3 is right. Okay, but in the equivalent exponential form, it's 2 to the third equals 8, right? And that's where you get that 3 from, right? For, if you remember from yesterday, right, when you try and answer a logarithm problem, it's 2 to what power gives you 8? 3. 2 to the third gives you 8. So that's why you get that. Okay? And of course, in general, if we have log base a of x equals b, then this rewrites to a to the b equals x. Okay? So that's from yesterday. Okay. Additionally, right, we learned 3 kind of basic properties, and we'll learn a few more advanced properties here. 3 basic properties. First, okay, log base a of 1. So no matter what your base is, right, log base a of 1 will always be what? Or a to what power will give us 1? 0, right? Anything to the 0th power gives us 1, so that's why log base a of 1 is always going to be 0 there. Number 2, all right? If we take log base a of a, so in other words, a to what power gives us a, or a to what power gives us itself? When you take a number and you raise it to a power and you get that same number again, what's that exponent have to be? 1, right? It's got to be 1. Okay? And then 3, log base a of a to the x. It's going to be x, right? Okay, and just as a little example of that, if you have like log base 20 of 20 to the 7th, the answer is 7, right? For this little example here, 20 to what power gives us 20 to the 7th? Well, the 7th power, right? 20 to the 7th power gives us 20 to the 7th. So that's the idea there. Okay, that's just a little quick example of that one. Okay, that's what we learned yesterday. So questions so far? Everyone comfortable with what we did yesterday? So that's what we did yesterday. Okay, all right. Here are our additional properties. As I said, there are 3 of them. Okay. So, first we have what I'll call the product property. Okay? You don't need to know the names. You just need to know what to do. Log base b of m times n. So in other words, why do we call it the product property? Well, because we have a product inside of our logarithm there. We have a product inside of our logarithm there. Okay. Well, what we can change this to be is log base b of m plus log base b of n. Okay, just like that. So multiplication inside becomes addition outside, okay? One single logarithm that has multiplication inside of it, right, becomes addition between two logarithms where the different pieces, right, are broken up there. All right. Next, we have the quotient property. Now, again, you guys are pretty good, I think, at doing patterns and things like that and kind of like converting things. So, for the product property, right, we have product inside of our logarithm. Quotient property, we have a quotient inside of our logarithm. Now, the product became a sum. What do you think is going to happen with quotient? Subtraction. Exactly right. Yep. Okay, so it'll be log base b of what should go in here. Log base b of what? M. Yep, very good. Minus log base b of what? N. Yeah. Okay, just like that. Okay. Now, if you remember, right, we've seen situations before where addition became multiplication, or actually multiplication became addition, right, and division became subtraction. You remember that's like kind of like our exponent properties, right? When you multiply two numbers that have the same base, you end up adding the exponents, right? And when you divide two numbers that have the same base, then you end up subtracting the exponents there, okay? So this is related to those same exponent properties, but they're not exactly the same, right? But they are related. They are related, okay? Because again, logarithms and exponents are inverse of each other. Okay. One more property here, and this third property is really an extension of the very first one. Okay, so this one is the power property. Log base b of m to the n power inside the logarithm there. Okay. Log base b of m to the nth power. Okay, well, when you raise something to an exponent, what does that mean you're doing? When you raise something to an exponent, what are you doing? Like, for example, if this was m to the third, what does that really mean to do? Yeah, multiply m by itself 3 times, right? So in other words, right, an exponent is just repeated multiplication, right? And, you know, in this case, it would be m times m times m times m times m times m n number of times, right? Okay, I know it's kind of weird I'm using m and n there. They sound so similar, but, right? So if we think back, that's really what we're doing right here, right? We're just doing multiplication, okay? And so I would have, you know, n of these m's being multiplied out, right? It'd be m times m times m times m times m. And so I can just add those things together. And when I add them all together, I will have n of those things. So this is really equal to log base b of m. N times log base b of m there, okay? We'll have n m's being multiplied together, right? N number of m's being multiplied together here. Well, that's just going to be repeated multiplication, and we know when we have multiplication, it becomes addition. So we're going to have n number of m's being added up there. So it's n times log base b of m. Okay, so the exponent inside goes out front, right? This whole quantity in here is being raised to the n, so we bring that n out front, and that gives us our properties there, our you know, third property. This is the third property here is going to be this super important property for solving exponential equations, because we're able to now, using a logarithm, we can take variables in our exponents and we can get them out of the exponent. See? When I take a log of m to the n, right? Imagine that was like x or something like that. I can bring that x out front of my logarithm, and now I can isolate x by dividing both sides by whatever log base b of m would be. I can get that n there by itself. So you can see now we're going to be able to solve exponential equations using these properties. Okay? So let's use these here. All right. Yeah, okay. So a couple of different ways we'll use these. For one way, we will simplify. Okay, we'll use them to simplify. I'll do 3 examples here. So number 1, log base 2 of 20. Now, is 20 a power of 2? It's not, right? 20 is not a power of 2. So I can't evaluate this, okay, like we did for the homework, right? The homework was easier to evaluate, but this, 20 is not a power of 2, so we can't break it up. But what power of 2 divides 20? Or what multiple of 2 can we use to divide 20? 4, right? So I'm going to take 20, and let's call that 4 times 5 instead, right? So it was log base 2 of 20. I'll break up the 20 to be 4 times 5. Right? That's equivalent. Since I have multiplication inside my logarithm, I can change that to what operation? Addition. It'll be log base 2 of 4 plus log base 2 of 5. Okay? Now, you might be like, Mr. Witt, you took one logarithm and you broke it into 2 logarithms and you're trying to say that's more simple? No, but we can evaluate log base 2 of 4 now. What is log base 2 of 4? Or in other words, 2 to what power gives us 4? 2. And so this becomes 2 plus log base 2 of 5. Okay? And there's our simplified form. Right? Can we divide 5 by any other powers of 2 evenly? No. So we're done here. This is as simple as we can make it. Okay, that's as simple as we get. Right, questions on that one? No questions? All right. Then let me do one more here. And then I'll show you another one. We'll do expanding after this. Log base x of x to the third times y. Log base x of x to the third times y. So I kind of got rid of all of our numbers, and now we're dealing with variables, which are still numbers, but anyway, you get the idea. Okay. How might we want to rewrite this one? How might we want to rewrite this to simplify it? I see multiplication. What can we change multiplication to be? Addition, right? So let's do that, okay? It'll be log base x of x to the third plus log base x of y. Okay. So, what can we make this? Yeah, just 3. There's 2 different ways you could think about making this 3. On the one hand, right, this is just what we did yesterday. You're looking at to try and figure out x to what power gives me x to the third. It's going to be 3. And then we'll have log base x of y. But another way you could think about simplifying this, well, we have x to the third right here. According to our power property, what can we do with that 3? Right? That's like our n here, right? What can we do with this 3 that we have for the x? Move it to the front, right? See how the n here moves to the front of the logarithm? So I could do that as well. Let me just show that over here. So it would be 3 log base x of x, right? I can move the 3 out front there. But what is log base x of x? It's just 1, right? What, again, x to what power gives us x? It's x to the 1, right? I think that goes back to our basic property number 2 there, right? Log base a of a equals 1. So when you take the log base of itself, you get 1. So this becomes 3 times 1, which also then gives us that 3 right there as well. Okay? So 2 different ways to think about evaluating this logarithm. Okay? 2 different ways to think about it then. All right. Can we simplify log base x of y at all? X to what power gives us y? Do we know anything about y to say anything there? X to what power gives us y? Can we say anything there? Do we know anything about x and y so we can say, oh, x is this power, or y is this power of x? No. We're done. This is the answer. Okay? So that's simplification, right? So how do we simplify here? Well, we were looking at our base. And we were trying to break up what was inside the logarithm so we would get, things that would simplify, right? So 20, because I could have broken up 20 into be 2 and 10. And that actually would have worked here. That would be one way to simplify it as well. Okay, I could also make 20 2 times 10. All right, and I could have simplified it that way because log base 2 of 2 is 1. Okay. So we broke it up so that we could simplify some of the numbers. Okay, that's simplification there. Questions on any of that? All right. The next thing I'll show you here, and I think I'll just go ahead and change to another piece of paper for this. Yeah, I'll go ahead and do that. Okay. So the second way we're going to be using these properties is to expand. Okay, expand logarithms. And what we're going to do is going to take a single log and expand it into multiple logs. Okay. Which we kind of did there. That's what we kind of did with simplification. We were kind of doing that. So let me just show you here. So okay, here's an example. Log base 6 of 5x to the third over y. Okay. Log base 6 of 5x to the third over y. So here we're trying to expand things out as much as we possibly can. Okay. So we have a single logarithm. We're trying to break it up into multiple logarithms here. What are some operations inside the logarithm that you see that we can expand on? Okay, so division. What does division change into? Subtraction, right? So let's go ahead and do that. And we're going to do it one step at a time here because I also see some multiplication, right? But we're going to do the division first because that's kind of like the major operation in there, right? First. So we'll say log base 6 of, okay, if I'm going to break up the division, I'll do log base 6 of what first? What's going to go in this first set? 5x to the third, the numerator, right? And then minus log base 6 of what's going to go in the second set of parentheses? The y. Okay, because we're dividing by the y. Good question, okay? So the question is, Mr. Wig, can't we just move this 3 to the front? Not quite yet, okay? What's being raised to the third power here, Julian? Just the x. If the 5 and the x were both raised to the third, then absolutely you can move that 3 out front. But moving that 3 out front says that it's telling us that both the 5 and the x are raised to the third, but only the x's. So we're going to break up the 5x to the third, then we'll move it out front. Okay? So we have a product here too, right? 5 times x to the third. What does a product expand to be? Multiplication expands to be what? Addition. So we'll have log base 6 of 5 plus log base 6 of x to the third minus still, right, the log base 6 of y. Okay? So you can kind of think of this as unsimplifying, right? We took one logarithm and we're unsimplifying. We're expanding it out. Okay? And now, Julian, what can we do? One more simplification step here. Now we can move this 3 in front of the logarithm right here. So we'll have log base 6 of 5 plus 3 log base 6 of x minus log base 6 of y. And there is our most expanded form right there. Okay. Questions on any of the steps there? Did I lose anybody or just confused about what I did? Anything? questions on any of that? The one thing we do want to keep our eyes on here, is after expanding things out, can I evaluate, for example, log base 6 of 5? Do we know a power of 6 that gives us 5? No. So I can't really simplify that. But if I did know an answer to that, I should write that down. Okay. Same thing here. I don't know 6 to what power gives me x. I don't know 6 to what power gives me y. Right? I don't know what those are. So that's the best we can do. That's that's as simple as it gets. But sometimes when you expand them out, you can simplify. And we should. Okay. Let me see. Yes. Okay, perfect. All right, let's try another one here. Expand this one out. Log base 3 of 3x, that quantity to the 4th power there. Okay. Log base 3 of the quantity 3x to the 4th power. You got it, exactly. So Julian pointed out here, right, okay, this one, since the entire quantity here is being raised to the 4th, now the first step we can do is we can bring that 4 out. Okay? Do you have to do that first? No. If you wanted to, you could expand the 4. You could say, okay, you can make this 3 to the 4th and x to the 4th, then break up the product, then bring the 4s out. It's kind of, you have some choice here. Okay? But let's bring the 4 out front since that's what Julian said there. So yeah, we'll say it's 4 log base 3 of 3x. So again, that 4 can go out front. We'll get to that in a second. We're not quite ready for that yet. We want to break it up first because it has a 3 and an x there. Correct. So the multiplication in here, it's 3 times x, right? So we'll make it 3 log base 3 of 3 plus log base 3 of x. But what about this 4? So obviously I think we're okay with the 4 being in front like this. Okay? But remember that the x was also being raised to the 4th. So I also need to put the 4 in front of the logarithm to the x as well. So the 4 distributes. Okay? When we break up this single logarithm here, and it already had a 4 in front, when we go to break up the 3 and the x there to 3 and then plus the x there, right? Log base 3 of 3 plus log base 3 of x, that 4 distributes to both terms. Okay? So it's 4 log base 3 of 3, 4 log base 3 of x, which should make sense because the 3 and the x were being raised to the 4th power there. So both should have a 4 in front. Okay? Now, Julian, yeah, go ahead and make your point there. So log base 3 of 3, Julian, is what? 1. And so this just becomes 4 times 1, which is just 4. And then can we simplify log base 3 of x at all? Yeah, 3 to what power gives me x? No idea. So we're just going to leave it. Okay? And so it's just 4. Sorry? Oh, what happened was my brain. Alrighty, questions on any of that? All right, so then I'm going to give you guys a couple to try here. And we're not quite done yet after this, okay, because I also want to show you how to go reverse from this. So take these multiple logarithms and condense them to a single logarithm. So what we just did is we took a single logarithm and expanded it to multiple. We also want to take multiple logarithms and condense them down to a single logarithm too. But here I'm going to give you a few to try before I go too crazy here. All right, so here's one. And again, just the directions are to expand. Okay. We'll say log base 3 of 4x. Okay. I want you also to expand log base 2 of 5 over 8. Okay, so expand that. Expand and simplify is what I'll say. All right. How about natural log of 6x squared over y to the 4th? And one more I'm going to give you here. Log base 2 of the square root of x. Okay, so try those 4 there. Again, use your properties, expand these things out. Use your properties, expand these things out. Sure. Use your properties, expand these things out. And I'll come around and help. I'll also put the properties up here on the board too. These 4 here a try. Okay, give these 4 here a try. Expand or condense. I got the properties written up on the board there for you. So give those 4 a try. Expand or condense. Just written differently because it's special, but it's you treat it. I mean, you still evaluate like you would anything else. The base is E, so Samantha, if you see ln like that, ln of something really means log base number E of that thing. Okay. I give you like 1 or 2 more minutes here, 1 or 2 more minutes, and then we'll get into condensing. Okay. Any questions on any of these? Anyone need some help when we look at something? All right. While you're finishing up there, I will write the answers up here too. Expansions. Okay. Number 1, you should have log base 3 of 4 plus log base 3 of x. Okay. Can we simplify log base 3 of 4 at all? Do we know a power of 3 that gives us 4? Do we know a power of 3 that gives us 4? 3 to what power gives us 4? Do we know how to answer that? No. Okay. Number 2, I didn't circle this answer. So we have division, right? Division, right? A fraction, division becomes, oops, subtraction. Whoopsies. I know. Yes, right. Okay, so that's why I wanted to leave that there, but I did make a mistake. Let me write that out here real quick. Log base 2 of 8 simplifies. What is log base 2 of 8? 4. Not 4. Yeah, remember you're talking about exponents here. So it's 2 to the 3rd that gives you 8. Okay, 2 to the 3rd that gives you 8. It would be log base 2 of 5 minus 3, yeah. If you wrote 3 minus log base 2 of 5, yes, that's not correct. That's not correct. If you did negative 3 plus log base 2 of 5, that would be okay. Because remember, subtraction, you can't just flip around subtraction, right? It's not the same thing. Anyway, this is the final answer right there. Okay. All right, number 3. So we have division first, so that changes to subtraction. But we still have a product in here, 6 times x squared. So I made it natural log 6 plus natural log x squared. I went ahead and brought the 4 in front as well there. And then I also ended up bringing the 2 in front there too. Natural log of 6, we don't have a nice way to evaluate that. I mean, you can use your graphing calculators at this point, right, because it's natural log, and there's a button for natural log, right? And then 2 natural log x minus 4 natural log y. Okay, and so there's that answer there. But we don't know the power of e that gives us 6, right? So we need to simplify that. Lastly, number 4, remember square roots. Square roots are the same thing as 1/2 exponents. And so we can bring that 1/2 out front, and then there's your answer, 1/2 log base 2 of x. Okay? Questions on any of that? No questions? All right. So I'm going to do 2 more examples here. I'll get you guys started on your assignment. And this has to do with condensing. Okay? Condensing. So, or, going in reverse essentially here. Expansion can be kind of tricky because you're not always sure when you're done. For example, here, you guys might have stopped right here at number 2, but you're like, oh, wait a minute, we can still simplify that to make it 3, right? But condensing is pretty easy to know when you're done because, well, you're going to be given multiple logarithms. You're going to take multiple logarithms and bring them down into one single logarithm, okay? right? Condensing, right? Condensing is to like make something more concentrated, right? So, right, you hear about like condensation, right? My car this morning had a lot of condensation on it. All the humidity in the air, because the temperatures went down, couldn't hold all that moisture in the air, so it ended up on my car, right? When you drink a cold drink in the summertime, right, with ice on it, all right, the ice cools the air around it, which causes water vapor to then show up on the outside of your glass, right? And that's why your glass gets all wet on the outside too, is because you have like an ice or a cooler drink inside there. It cools down the air. The water and the air condenses into a liquid. Okay? So now we're going to take our logarithms here and we're going to condense them down to a single logarithm. Okay? So we're going to work backwards now. So what might be a good first step to do here? Ideas? All right, how about this? I'll start right here with this. This 3, what can we do with this 3? So we're gonna bring it up inside. We're gonna bring it up inside as an exponent. We're gonna undo what we have written there, and we're gonna say, okay, this is the same as log of 9 plus log of 2 to the third, right? So we're gonna bring that 3 inside there, up as an exponent. Okay. All right, now what? Well, we have log plus a log. When we have addition between two logarithms, we can change that to what? Multiplication, right. So addition between two logarithms, we're going to make it multiplication in a single logarithm. So these two will combine together to give us log of, and what will be inside now? What gets multiplied together? The 9 and the 2 to the third. But what is 2 to the third really? 8. So it's really 9 times 8. And what's 9 times 8? 72. Okay. Minus log of 3. Okay, now when we have subtraction, what can we do with our two logarithms here? Make it into a single logarithm with division. So log of 72 over 3. But what is 72 divided by 3? It simplifies, actually. It's going to be 24. Okay. Now, can we simplify log of 24 at all? Like, does it cancel out or anything? When you have just a logarithm, right, what base is here? 10. Is 24 a nice power of 10? No. So we'll just stop right there. We're done. And we're into a single logarithm. Okay, technically you could stop here because technically we've done what the directions say to do, condense to a single logarithm. So we took all of our three logarithms there, we put them all back together. There's a single logarithm, but hey, why not just simplify it, right? All right, questions on any of that? All right, we'll do one more here. Let's use natural log. So natural log of 4 minus 3 times the natural log of 3 plus the natural log of 12. Okay, last one here. I'll get you guys started on the assignment. Okay. All right, first step here. Can we go ahead and put these two logarithms together? Can we put these two together right here? Not quite. We have this 3 in front. So we're going to have to take care of that 3. All right, so I'm going to make it natural log of 4 minus natural log of what here now? What happens to this 3 in front? It becomes the exponent. So it'll be 3 to the third. Okay, so again, that 3. Yeah, it'd be 27. We'll get to that. Now I see subtraction. What does subtraction mean to do? We're going to change it to division, right? So it'll be natural log of 4 divided by 3 to the third is 27. Okay, and we still have the plus the natural log of 12 there too. Okay. So again, when we are condensing, subtraction between two logarithms comes together as division inside. Okay. Now we also have addition. Addition between two logarithms becomes multiplication. Okay. 4 over 27 times 12. Which you can make that really 12 over 1. Okay. And the 12 and the 27 simplify, right? I can divide 12 and 27 both by what number? 12 and 27 both are divisible by 3. So I make that 4, make that 9. And so we end up with the natural log of 4 times 4 is going to be 16. 9 times 1 is going to be 9. So it's a natural log of 16 ninths. And we can't simplify that any further, so we're good there. Again, technically, you are done here because we got a single logarithm. But again, I wanted to simplify it since we could. Mm-hmm. All right. Questions on any of that? Okay. So again, what you're going to be doing then for your assignment here is you're going to be working both forwards and backwards with these logarithm properties and simplifying where possible as well. All right, let me get you guys your assignment then here.